Hello all, this is my circuit setup. As we can see this cable here, the cable consists of 3 wires, the red wire, the black wire and the green wire. For me the red is the live wire and the black is the neutral wire and the green is the ground wire. Basically the red, the live wire and the neutral wire carries AC voltage, and I connected the live wire of the cable to the transformer via fuse, because if the current exceeds certain limits the fuse will open, hence our circuit will be open circuit, so nothing damage occurs to our circuit. In the similar way I connected the neutral wire of the cable to the another terminal of the primary side of the transformer. Since here the ground wire is unused, so I insulated with the tape. Coming to the secondary side of the transformer, we can see the two yellow terminals, which is basically VDD. So I am using only one side of one terminal, so I insulated other terminal with the tape. Here the middle one is the middle terminal is the ground, so middle terminal is the ground, so it is called a center tap because the centered one is the ground one. I connected the VDD through the breadboard via fuse due to the same reasons as we discussed in the primary side. The ground terminal I connected to the breadboard. Here we can see that our household voltage is 230 volts. It is fed to the 15015 transformer. It steps down 230 AC voltage to 15 AC voltage, and I am feeding 15 AC voltage through as my input through the breadboard. As we can see the diode setup. During the positive of cycles, the two diodes will be in forward bias, hence it conducts, and the remaining two diodes is off. During the negative of cycles, another two diodes will on and the remaining two diodes will off. And we can see the rectified output at the capacitor, and we can see the rectified output here. And this rectified output, the rectified output is only the positive of cycles. These diodes converts the input waveform to the positive of cycles, so it is called as the rectified output. Since the rectified output is AC voltage, here we need to convert AC to DC, hence we need a filter, so I am using here shunt capacitance. When this rectified output, which is AC voltage, is sent to the capacitance, we know that the capacitance allows AC and blocks DC, so we can this AC voltage are passed to the capacitor and it is grounded, hence all the AC components are grounded, and the remaining are DC, and hence the DC voltage, the output of the capacitance is DC voltage, and it is sent into the IC. As we can see, IC contains 3 terminals. First one is the input one, and the middle one is the ground, and the third one is the output terminal. The output of this capacitance is sent to the input of the IC, and in the middle terminal I grounded it. Since it is a DC, for example, say it is a 15 volts. When the 15 volts is sent into the IC, here the IC is 5 volts voltage regulator. Whatever the input may be, it regulates the voltage to the 5 volts. For this use we are using this IC, and we can check the workage of the circuit via LED. The output of this IC will be the 5 volts because it is a 5 volts positive voltage regulator, so it regulates voltage up to 5 volts. It can take maximum input voltage. It takes the input voltage from 7 to 25 volts, and it provides the output only 5 volts. As we can see the 5 volts which is in DC, and we can check the working of the circuit using this LED. So let's see the working of the circuit. Yes, here we can see the working of the circuit. Since the IC provides 5 volts DC, hence I am using a resistance and I am passing it through the LED to check my circuit. And here we can see the multimeter reading, which is showing the 5 volts. Thank you.